Hello, Christian McDonald here, and in this video I want to talk about some of the changes that have been made since the last progress report video on the pfSense WireGuard package that I am developing. So I said in the last video that I was going to try to do these once a week. Well, I think enough has changed since my first video on Friday that a new video is in order. And I also have a suspicion that more and more people are going to find the package and want to play with it. So I figured they need to have the latest information. So even if you're brand new or you're a veteran, so to speak, and you've been with me for the last week or so, this is going to be a video that you will want to see because there has been several major changes since the last report that I want to talk about. The first thing that I want to talk about is a pitch. I have GitHub sponsors running, and I'm not really interested in making a living off of maintaining the WireGuard package, but I would like to potentially recuperate some of the cost and my time, not only up until this point, but also as the maintainer of the package moving forward. So if you're interested in that, you can find my GitHub sponsors page on my GitHub page, and there'll be a link in the description. So there has been some pretty big changes from the last video that we need to discuss, because a few of those changes are breaking changes. So if you are going to be upgrading from version 0.0.5 revision 1 to the next version, which is going to be version 0.0.6, which will be released by the time this video is out, you're going to need to make some changes and really pay attention to a few things. The first major change that is coming is a brand new startup procedure. I know that in the last video I was pretty hyped up about the way that I was protecting WireGuard interfaces that were assigned to pfSense interfaces so that the system was never in a situation where it could never boot. And I forgot about something that I stumbled across 2 weeks ago by looking at some code by another project that was attempting to bring WireGuard Go to pfSense. This project was by Askrod. You can find it on GitHub. It's stale at this point. It's based on WireGuard Go, and the implementation is not as great for that reason, among other reasons. But one thing that he mentioned in his code that I forgot about, even though I did know about this, was that if there are interfaces that are created by a package or any other if there's interfaces in pfSense that begin with certain prefixes, pfSense is not going to care if those interfaces are not available immediately right at startup. And in fact, in his primary PHP file, he even says, rather than using traditional WG names, we prefix with ton so that pfSense doesn't freak out about non-existent interfaces on boot. Instead, pfSense just ignores it. And technically, WireGuard interfaces are ton anyway, so we aren't lying. These 3 lines of comment are, at this point, probably the most valuable aspect of the project by Askrod. And this is why we have our first major breaking change since we started this project, and that is we are renaming WireGuard tunnels from the traditional WireGuard WG names to ton_WG. And by doing so, what we do is we eliminate the chance that that pfSense, when it reboots and it's looking for these interfaces, that it won't ever trigger an interface mismatch exception that would cause the firewall to not boot. If you don't have the WireGuard package, those interfaces are just going to sit stale, but it's not going to put the firewall in a state where it cannot start. So issue number 27, under the new startup procedure concept, I kind of talk about some of the logic behind this. So basically, we're going to be renaming WireGuard interfaces from WG to ton_WG. Remember that ton interfaces are layer 3 and WireGuard is layer 3, so we're not lying, right? But the reason why we're doing this is because built into pfSense, under the util.inc file, there is a routine called isInterfaceMismatch, and this is the function that is called during the boot up process that is the deciding factor of whether or not pfSense is going to trigger an interface reassignment screen or not. And in fact, if you look at this code, I actually copied and pasted the function into the issue just for future reference. There are like 10 or so interfaces that will not trigger an interface mismatch. You can see that includes things like GREs and GIF tunnels, IPsec, OpenVPN, TAP/ton, etc. So we're just going to use ton as the prefix because by doing so, we are not having to provide the firewall with any extra bits. In fact, what we're doing is we're just using logic that's already built into pfSense. So we're not giving it any more than it's giving us. It already is built to handle these interfaces that start with TUN. So if we just name our interfaces accordingly, pfSense is just going to ignore them, and our WireGuard interfaces are guaranteed to not cause a mismatch error on startup. So this is big. This is huge, because what this means is that it means that our config.xmls, when you back up a config and you restore it, you can restore these configs on any platform, any hardware platform, a fresh install, etc. And because we're not tied to having extra bits or running early shell commands, it just is going to work. So all of the early shell commands are gone. All of the extra scripts are gone. We're just relying on the feature that pfSense will ignore, interfaces that start with these 10 or 11 or so prefixes. And we're going with ton because, again, WireGuard tunnels are layer 3 and ton tunnels are also layer 3. And this just works. So it works really, really well. Now what that means is that although our WireGuard tunnels are no longer created early during the boot up process, because they no longer have to, we're just going to rely on building our tunnels when packages are started organically in the pfSense boot process. So remember that packages always start last, and that was the challenge that I was working around, trying to keep our tunnels named WG. But as soon as I broke out of that, and I was reminded of the point by Askarad on his project, this is going to work so much better. Again, our configs are going to be portable, and as soon as the package is reinstalled and resyncs, it's going to pick up those configs, and it's just going to work. So this is really, really big. Now, what this means to anybody who is coming from a version less than version 0.0.6, so I'm bumping the version because this is a breaking change. You're going to need to do some cleanup of your config file. I am not interested at this point in the project because it's experimental and we're sideloading packages. I'm not going to bother creating cleanup code. So what that means is that you will need to go and edit your config.xml and make some changes. So under issue number 27, this is where we're going to be discussing that. So if you have any questions on what that process is going to look like, jump into GitHub and go to issue number 27, and you can talk about that here. But basically what you're going to have to do is you're going to have to edit your config.xml and remove any reference, any early shell commands that the package was installing, and also rename any interfaces to from the old WG naming to the ton_WG naming. And then there's also a point here that you need to delete temp/config.cache to make sure that the config.xml is reparsed, I guess, so that those settings are applied. So that's a big change. What this means is another way that you can do this too, and that is just go into the interface, and you'll still see your old WG0, WG1, etc. interfaces. You'll just need to go and delete those. And as soon as you delete them and start creating new tunnels, those new tunnels are going to pick up the new naming convention of ton_WG and then the number. So that's a big change. So again, if you're coming from an old version, just do an audit of your config.xml and make sure that it's cleaned up. Some of the things that you'll want to look for, you can actually look at your config.xml, by the way, if you go to diagnostics and edit file, and then you can just go to conf/config.xml, and this is the same file that you download when you back up your configuration. And what you want to look for is under interfaces, if you have any assigned interfaces, just make sure that they start with TUN, and then you'll want to go to installed packet. You also want to go to system, go down to the very last tag, the system closing tag. Let me just look for that. Oops. Let's see, system. Yeah, so right here, this system closing tag, all of the early shell commands are added here. So if you never had any, delete all of them, or just delete the ones that were laid down by the package. And then at that point, you'll also want to scroll down to the installed packages tag. And this is where we're now dumping the WireGuard configuration. And a couple of things you'll want to do here is, again, make sure that you renamed the tunnels and whatnot. And there's also a tag that we're not using anymore, and that's blur secrets. And I'll show you that in just a second, but you can just delete that blur secrets line, and that won't ever give you any trouble. I mean, you can keep it. I'm just not reading that value anymore because I've changed it from blur to hide, and I'll talk about that in a second. You can also delete keep extras because again, we're not leaving bits on the firewall. There's nothing to keep. When you remove the package, everything is removed unless you've decided to keep your configurations. There's no extra bits installed. So we can also delete that tag as well. So really the only two tags you need under config would be keep config and hide secrets. And I'll show you that in just a second. So I'll go ahead and save that, and we're just going to go back and go back into the package. So again, we're going to go back to VP and WireGuard and take a look at some of the changes here. Again, the tunnels, the names of the WireGuard tunnels have changed. Instead of WG naming, we're now doing ton_WG naming. I want to go to settings really quick. I've actually removed the extra scripts option again because that's no longer applicable here. But the other thing that I've done is I've renamed the blur secrets to hide secrets. I came across an academic paper within the last couple of days that demonstrated that using deterministic blurring, like that, what's done in CSS, is trivial to crack. Deterministic blurring meaning that the same letter is always blurred the exact same way. So as long as you know the parameters of the text shadow CSS property, that's deterministic. You can just run that as many times as you want with known characters, and you can easily produce a neural network that can easily break those blurs. So the best way of doing this is actually just to hide the secret. So instead of blurring, we're just going to hide them, and what that means is the secrets are now just password fields, so you can't see them anymore. And in fact, you almost always never need the private key anyway. At least you're probably not going to extract the private key. You might put the private key in if you're recovering a configuration or reusing a key. But this feature is going to be enabled by default. If you want to turn it off, you can turn it off. Not a big deal. And again, the same thing applies for your pre-shared keys as well. That's now a password field. In this example, I've got two tunnels, ton_WG0. This is not assigned to a pfSense interface, but just to give you something to look at here, this tunnel I'm actually using for my phone. So again, you're seeing there's handshakes and I'm transferring packets and everything worked really well there. So now what I want to do is I want to show you the the boot process. So again, on this demonstration, we have an assigned interface to a pfSense tunnel. Let's see. Yeah, this Vulture instance is not. It's the lowest size, the lowest spec instance, so it's not the fastest. Let me just restart this here. I'm also coming in on my WAN IP, so I might need to bounce pfCTL. Okay, no, we're good. All right, so again, I've got LAN as ton_WG1. I've got an IP address here and a subnet and whatnot. One of the things you can also do, again, is you can add virtual IPs. So if you have a tunnel, an assigned tunnel that you need more than one IP, there's nothing stopping you from coming in and adding an IP alias to this and adding another address. So that works as well. So it just works. It works really well. The other thing too is that if you're going to be routing over these over your assigned interface, you're going to have to create your own gateway. So you're going to treat this as any other WAN, and you're going to have to create your own gateway definition. Again, just like any other WAN. So you go here, you go to LAN under IPv4 upstream gateway. You can just hit Add New and give it a name and an IP address, and you've got your gateway. So again, that's a change from the 2.5.0 WireGuard implementation. You have to make your own gateways now if you want to route over them and do policy-based routing. Other than that, I think we're ready to reboot, so you can see how that works. So let's go ahead and do it. So over here, I've got the console for this particular pfSense box, and we're just going to type 5 to reboot and Y to accept that. And we're just going to reboot. You can see that it's stopping the WireGuard package. I also have PF blocker and whatnot installed too, just for testing to make sure that packages aren't fighting with each other. I know that that's a popular package. I use it myself. And we're going to boot, and we're going to take a look at how this works here. So again, this is about the time where your early shell commands would kick off. That's no longer required. So at this point, it's already ignored those tunnel interfaces. The interface mismatch check has already happened. And we're now starting the web configurator. We're getting close to the end of the boot process. And now we're going to start packages. You can see that the WireGuard package started, and we came up. And again, remember that we had the ton_WG1 tunnel assigned to LAN. It came up. I don't have anything on the far end, but we can click on WG show. I have no peers assigned to this, but it created it, no problem. Let me make sure that my phone just should start to connect. Or did I turn that? I think I might have turned it off. Let me bounce that really quick here. I did turn it off. So let me just recycle, activate, deactivate that. And again, there we go. So I'm getting handshakes from my phone. I'm pushing packets. Let me also, just to show you this is kind of cool. I'm going to go ahead and assign an interface. Oops, I'm going to log back in here. I'm going to take this interface that I'm using for my phone. Remember, that was not assigned. And I'm just going to go and assign that. So that's WG0. We're going to click Add. And we're going to click Save. And we're going to go into that. And I'm going to enable it. We'll keep it opt1. We're going to set a static IPv4. And remember, that was 10.1.15.1. And that's a /24. Click on Save. And over here on the console, we'll just do some checks here. ifconfig to make sure that everything is good. And again, you can see that the WG0 is picking up the right IP address. Now, it is defaulting to the default MTU of 1500. I think that's fixed. So in theory, WireGuard should allow an arbitrarily large MTU inside the tunnel. So traffic inside the tunnel, you should be allowed to pass an arbitrarily large MTU. So I would keep it at 1500. If you have problems, you can come back into the assigned interface and whack this down to 1420. and also, excuse me, whack down the MSS to 14.20 as well. We can click Save and Apply just to show you that that also works. And we'll run an ifconfig here again just so you can see that that did change. And again, remember, we're on WG0 and we changed that to 14.20. All right, so let's go and look at, make sure that our firewall rules are set correctly, because opt1 probably doesn't have any rules. So let me just add quickly a pass all rule so we can actually get traffic out and use this pfSense as my gateway on my phone. And let me make sure that my NAT rules are still good. Outbound NAT, we want to rewrite 10.1.15.0/24 to the WAN IP address, and we want to do that. And again, because we have assigned addresses, your automatic outbound NAT rule generation also works too. So let me go back here and let me go ahead and make sure that my phone is still working. Make sure I've still got internet on my phone. Let me do an IP. Let me just go to IP chicken. Yep, and on my phone I see a public address of 137.220.58.121, which is the so it's working. Now I wanted to show you something, because there was a bug on Redmine that traffic graphs for WireGuard tunnels wasn't working, and I'm here to tell you that they now work. So if I go here and let's look at opt1, and I'm going to go ahead and run a speed test. So this is one of the benefits of having the kernel code updated and being worked on aggressively. Things like this are now working. So if I go and run a speed test on my phone, you're going to see the traffic graph is going to kick off, and it works. And I'm looking at a WireGuard interface. So it's working. So again, there's a lot of bugs from the Netgate implementation in 2.5.0 that now it just works here. Traffic graphs work. The MTU bug is gone. It just works. Everything works, and it works really, really well. So that is pretty much the extent of where I'm at so far. Again, this version has some breaking changes. You want to make sure that your config is cleaned up, but we are closer than ever to feature parity, and it's really exciting. So again, if you are interested in supporting this project, you can find my GitHub sponsor in the description below, and let's work together and make this the best WireGuard implementation yet on pfSense. So thanks for watching, and we'll see you in the next video.